First one, see this question. See this question taken from the NCERT textbook. See this question. Please read this question. Question is, there is a certain sum of money which becomes 2.25 times of itself in 2 years. 2.25 times of itself in 2 years. Find the rate of interest if compounded annually. Question is, in rate of compound interest, a certain sum of money is becoming 2.25 times of itself. Method 1. Method 1. Method 1. If I take successive change method, depending upon your comfort, you take any method. Successive change method. Suppose, for example, if it is 20%, if it is 1 by 5, denominator it is always the principal, so it is 5. 1 increase, it is 6. Yes or no? 1 increase, it is 6. Initial value is always the principal. Initial value, it is always the principal. Final value, it is always the amount. Final value, it is always the amount. It is always the amount. Let us see the successive change method. So, for how many years it is? First we will underline. It is for 2 years. Initial value, it is principal. Final value, it is the amount. This is the initial value and it is the final value. This is for the first year. Same rate of interest is there for the second year. Initial value, principal. Final value, amount. So this will become P square is to A square. P square is to A square. A certain sum of money is becoming 2.25 times of itself. That means A by P, it is 2.25 by 1, which is 225 by 100. 225 by 100. 225 by 100. So P by A will become 100 by 225. 100 by 225. I hope it is clear. So P square is to A square. P square is to A square. How much it is given? In 2 years. Sorry. In 2 years it is becoming. So what we'll do is, this P square is to A square. It is given as P square is to A square. It is becoming 100 is to. After 2 years it is given, sir. So this becoming 100 is to 225, because a certain sum of money becomes, that means amount is becoming 2.25 of principal, which is 225 by 100. Initially if I gave 100, after 2 years I will get 225. So this is can be written as P square is to A square. 5 20s are 5 45s are 5 4s are 5 9s are. So P is to A, it is 2 is to 3. 2 is to 3. So in 2 is to 3, 1 year it will be, there is an increase of 1 on 2. It is 50%. It is an increase of 1 on 2, which is 50%. This is a successive change method. Should I use this method in the examination? Ideally not. Idea is to give you from now onwards, if it is 2 years, this will become P square is to A square. If it is 3 years, it will become P cube is to A cube. If it is n years, this will become P power n is to A power n. I will use this in some problems in the next upcoming time. P square is to P square. Initially, I took some money from my friend P. After 1 year, I will give the money with interest, which is P is to A. Second year, I took some money. After second year, I will give. So, P into P, because it is itself in 2 years, rate of interest every year it is same. P square is to A square. Sir, why it is 100 is to 225? If it is 1, this will become 2.25. If it is 1, 2.25, 225 by 100. 4 is to 9, 2 is to 3. 1 by 2 it is 50 percentage. 1 by 2 it is 50 percentage. This is one way to solve, which is method number 1. Method number 1. I hope method number 1. From method number 1, this is the learning which I am going to use it. Method number 2. Question could be any, sir. Question could be any. Method 2. What is given in the question? Amount is 2.25 times the principal. 2.25 times the principal. Method 2. Method 2. Different angles to solve a problem. We can use a digital sum concept. We can use digital sum concept. This is amount equivalent to P into 1 plus R percentage power n. So it is 2.25 P equivalent to P into 1 plus question mark percentage power 2 years. Question mark percentage power 2 years. Now see here, very easy, just by looking at the answer we will get it. 2 plus 2 it is 4, 4 plus 5 9. Answer digital sum is 9. Left hand side digital sum is 9. Right hand side digital sum should also be 9. Right hand side digital sum after putting the answer option, it should be 9. First option 25 percentage. PP cancel. 100 plus 25 is 125 by 100 power 2. 125 is 1 plus 2 3, 3 plus 5 8, 8 square. It is 64, 6 plus 4 10. It is 1. This cannot be. If I put 50 percentage, 150 by 100 power 2. 150 it is 6. 6 square 36. 3 plus 6 it is 9. 6 square 36. 3 plus 6 it is 9. I hope it is clear. So answer is 50 percentage. See, 125 will become 125 square. 2 years means 2. 8 square 64. 6 plus 4 10 1. 50 will become 150. 6 square 6 square it will become 36. Sir, why can't I take what is the option? What if it is 41 percentage? 41 percentage, that also a smart student might get. If it is 141 by 100 square, sir, digital sum it is matching. 1 plus 4 5, 5 plus 1 6, 6 square 36 9, it is matching. Use the rightmost non-zero digit. What is the rightmost non-zero digit? 5. What is 1 square? 1. Is 5 equivalent to 1? No. So 141 can be eliminated. 141 can be eliminated. One is digital sum approach. Another is successive change approach. Another is method number 3. Method number 3. We can use successive percentage approach. We can use successive percentage approach. Successive percentage approach. What is successive percentage approach? A plus B plus AB by 100 percentage. A plus B plus AB by 100 percentage. Final value it is there, initial value. Final value it is amount 2.25. Initial value it is the principal. 1 became 2.25. How much percentage it is growing? Suppose if I multiply by 100, 225 and this is 100. How much is the growth? Growth is 125 percentage. 125 percentage growth. On 100, 125 it is growing. So it is 225. So overall percentage for 2 years. If I apply successive percentage, overall how much I should get successive percentage? 125 percentage I should get. 125 percentage I should get. What is the first option? 25. 25. 25 means 25 plus 25 plus 25 into 25 by 100. This cannot be. It is around 50 percentage. Second option, if it is 50 percentage, 50 plus 50 plus 50 into 50 by 100. 50 into 50 by 100. 100 plus 25, 125 percentage. Third value, if 25 is not giving you the answer, if 25 is not giving you the answer, how come 15 will give you the answer? 25 is incorrect. Why? Because A plus B plus AB by 100. AB by 100 is very small compared to A plus B. So the value will be very close to A plus B. 75 plus 75. Answer is 150 percentage. Answer is 150 percentage. 150 percentage. Greater than 150 percentage, but we require less than 150 percentage. One is a successive change concept. One is successive change concept. What is the another angle? Digital sum concept. Another is successive percentage. Please remember, in my class, I am not going to tell you why this is the right answer. Like that, thousands of YouTubers will tell you why it is right. I am going to tell you how you can eliminate the other answer options. Right? My experience is more with giving a very, very good smart answer options. 25, 15, 75. These are not possible. These are not possible. I hope the idea it is clear. Now, these method 1, method 2, method 3. Digital sum, I hope it is clear. Successive percentage, and we did successive change. Now, what is that we discussed? Now, if you see here, listen carefully, sir. What is that we discussed? P, A1, A2, they are in geometric progression. Principal, amount at the end of the year, and A2, they are in geometric progression. In geometric progression, multiplication factor will be same. Multiplication factor will be same. This is another point. For example, 2, 4, 8, 16, 32. They are in geometric progression. Multiplication factor, it is 2, which is the same. I hope it is clear. Same like what we do it in algebra. The same thing we can apply it in compound interest. P, A1, A2. It is the same. What is multiplication factor here? Multiplication factor is X, which is R percentage more, which is 1 plus R percentage. This is what we did it. Multiplication factor, it is same. So X is R percentage, 1 plus R percentage. What is given in the question? Principal amount at the end of the first year, amount at the end of the second year, which is 2.25, it is given. 2.25 it is given. If you observe closely, 2.25 is 1.5 whole square. Amount at the end of the second year, it is 1.5 whole square. That means this would have been 1.5. Multiplication factor remains the same. This would have been 1.5. Yes or no? Multiplication factor will always be same. Answer, it is 1.4 whole square. Suppose if it is 2 and 4. 4 it is 2 square. So 2 is multiplied by this value. So 1.5 whole square. There are two time gaps are there. 1.5 whole square. Just now we discussed. For 2 years. For 2 years it is 1.5 whole square. So if it is for 1 year, it will be 1.5 whole square. I told you just right now. So what is 1.5? 1.5 is the multiplication factor. 1 plus R percentage is 1.5, which is 1 plus 0.5. So R percentage is 50 percentage. 1 plus R percentage is 50 percentage. I hope the idea it is clear. This is a very, very interesting concept, sir. Very, very interesting concept. R percentage is 50 percentage. Sir, which method I should use? I would suggest solve all the compound interest 6 sessions, or probably it could be another 7 to 8 sessions. Watch the entire lectures, write the notes, then your conscious will tell you that this is the method which I am going to follow, and use that method in all the problems. But as a teacher, when I am solving a problem, I will tell you various angles I looked at this problem, so that you understand various approaches, right? Even if you forget one approach, another approach also you can do it. It is 1.5 whole square. It is similar to A AR and AR square. So it is into R and it is into R. R square 1.5 whole square. So this will become into 1.5 and this will become into 1.5. Geometric progression, compound interest, amount principal, amount after equal time intervals, all will be in geometric progression. All four angles, I hope it is clear, right? Four angles, I am sure it is clear. Let me solve the second question. Now see here. So from now onwards, what we will do is, we will use these G multiplication factor concept. Another question, a certain sum of money, please read the question first. A certain sum of money becomes 512 by 162 times in itself in 4 years. That means there is a principal, amount after first year, amount after second year, amount after third year, and amount after fourth year. So all are at equal time intervals. So multiplication factor will be same. So this is 512 by 162. Check it out whether it is of the form power 4, which is of the form power 4. YET, let us do it. 281s are 256 are. So it is 4 by 3 power 4. 4 by 3 power 4. 4 by 3 power 4. At the end of 4 years, it is 4 by 3 power 4. So it is into 4 by 3. Multiplication factor remains the same. It is into 4 by 3. It is into 4 by 3. And it is into 4 by 3. Multiplication factor is x, which is given by 1 plus r percentage. It is 1 plus 1 by 3. R percentage 1 by 3. So r will be 33.33 percentage. 33.33 percentage. Is the idea clear? 33.33 percentage. Very, very easy to do it. In fact, you can also use the P power n and A power n concept. That is what I used it. This method 1. Actually, that is what I used it. Inherently, I am not showing you. It is 512 by 162, which is 4 by 3 power 4. After 4 years, it is power 4. There are 4 years. After 4 years, it is power 4. So every year it will be multiplication factor 4 by 3, 4 by 3, 4 by 3, 4 by 3. Multiplication factor is given by 1 plus r percentage. R percentage is 1 by 3. So r percentage value will be 33.33. 33.33. Now, if you see here, the same thing I did it here, sir. Method 2. Initial value, it is the principal. Final value, it is the amount. These for the first year. Second year, initial value, principal. Final value, amount. Third year, initial value, principal. Final value, amount. Fourth year, initial value, principal. Final value, amount. So after 4 years, it will become P power 4 is to A power 4. How much it is giving? It is 5 by 12 by 162 times of itself. If the principal is 162, final will become 512 by 162 into 162. So it is into 512 by 162 into 162. So this is 281s are 256 are. So P is to A. It is 3 is to 4. 3 is becoming 4. Extra 1 on 3. Extra 1 out of 3. 1 by 3. What is the answer? 33.33 percentage. This is exactly the same representation. One is I am doing horizontally. Another is I am doing vertically. In a compound interest related problems, initial value is always the principal, final value it is always the amount. Final value it is always the amount. Yesterday we have seen how to write down this one, 20 percentage 1 by 5. 5 1 increase 6. 5, if it is 16.67, 6 1 increase 7. I hope it is clear. 81 is to 246. 81 is to 246. Now if you see here, this one way to look at it is, for me I'm least interested in teaching one methods to you. This method 1 multiplication factor, another is a successive change method. Now if you see here, now I should have explained some more problems here. Write down some foundation problems. Foundation problems with concept. If a final value is k times the initial value, if a final value is k times the initial value, percentage increase is given by k minus 1 into 100 percentage. If final value is k times the initial value, percentage increase is given by k minus 1 into 100 percentage. K minus 1 into 100 percentage. Sir, why k minus 1 we got? It's a very easy concept. Initial value if it is 2. Final value it is 8. Final value it is 8. What do you mean by percentage increase? 2 is becoming 8. How many times it is going? 4 times. So percentage increase is given by final minus initial by initial. Why? Because change by initial. 300 percentage increase. 300 percentage increase. Am I right? 8 is 4 times 2. Already 2 is there. Another 6 we have to add. Percentage increase. Increase means how much we have to add to 2 to get 8. I need to add 6 to 2. 6 by 2. It is 300 percentage. 6 by 2. It is 300 percentage. Why it is k minus 1? If final value is k times initial value. K into I minus I by I. I if I take common, this will become k minus 1 into 100 percentage. If the final value is k times initial value, the percentage increase is k minus 1 into 100 percentage. K minus 1 into 100 percentage. Examples. A certain sum becomes 6 times in 9 years to become 16 times. How many years are required? Under simple interest. First we will do simple interest. Write down this question. A certain sum becomes 6 times in 9 years. To become 16 times, how many years are required under simple interest? No formulae, nothing. Just a simple question. A certain sum becomes 6 times in 9 years. To become 16 times, how many years are required? First read the definition. A certain sum becomes 6 times. Final value is becoming 6 times. If final value is becoming k times, percentage increase is k minus 1 into 100. If the final value is becoming 6 times, percentage increase will be 6 minus 1, 500 percentage in 9 years. But I don't want 500 percentage. Final value is becoming 16 times. 16 times means percentage increase will be 1500 percentage. 0 0 cancel. 5 3s are 15. 9 3s are 27. Answer for this question is 27 years. Answer for this question is 27 years. Again I am explaining. Fundamental concept, sir. Basic concept. If the final value is k times the initial value, percentage increase will be k minus 1 into 100. If the final value is 6 times the initial value, percentage increase will be 6 minus 1. 5 into 100, 500 percentage. 500 percentage in 9 years. 16 times will become 1500 percentage in how many years? 5 3s are 15. 9 3s are 27. Not a single formula I used it to solve this foundation level question. Suppose if it is 8 times in 12 years. 8 times in 12 years. 22 times in how many years? 22 times in how many years? Tell the answer orally, sir, once the fundamentals are clear. 8 times in 12 years. Final value is 8 times the initial value. Percentage increase will be 700 percentage in 12 years. 700 percentage in 12 years. To become 22 times, it will become 2100 percentage. How many years? 0 percentage. Answer is 12 threes are 36. Answer is 12 threes are 36. Are you all with me? Very, very easy question. 5 times in 20 years. 5 times in 20 years. 11 times in how many years? All are in basic foundation level questions. 5 times in 20 years, 11 times. 5 times means 400 percentage. This will go in 20 years. 11 times means 11 minus 1, 10. 10 into 100 percentage. How many years? 0 percentage. 4 5s are 20. 10 5s are 50. How many years it will take? 50 years. Very, very important key point. If the final value is k times the initial value, if the final value is k times the initial value, percentage increase will be k minus 1 into 100 percentage. Very, very important key point. Sir, why we are discussing this one? It helps us in case if you forget multiplication factor concept, you can use this concept and eliminate answer options. How to use this concept we will see. I hope it is clear. Final value is k times the initial value. Percentage increase is k minus 1 into 100 percentage. Now let us see this question. This question, how to do it? A certain sum 512 by 162 of principal in 4 years. In 4 years, find the rate of interest. Find the rate of interest percentage. This is the question, right? Let me write down the options. Options is 33, 22.22, 25, 27.5. 33.33 and the next one it is 22.22, 22.22, 25 and 27.5, 25 percentage and 27.5 percentage. Listen carefully, sir. Just by sheer observation you will get the answer. Just by looking at it, you will get the answer. So initial value, if it is 162, final value, it is 512. 512. Am I right? So it is into 3. 162 into 3, it is 486. 512 is still greater than 486. That means it is greater than 3 times. It is greater than 3 times. If final value is greater than 3 times, overall percentage increase should be greater than 200 percentage. Overall percentage increase. If the final value is k times the initial value, if final value is k times the initial value, percentage increase will be k minus 1 into 100. So overall percentage will be greater than 200 percentage, greater than 200 percentage. These are all little complicated values. Let me take 30 percentage, 4 times. It is in 4 times, right? If I take 30 percentage, this will be 69 percentage. This will be 69 percentage. This will be greater than 138 percentage. Am I right? Greater than 138. This is greater than 200. Answer should be greater than 30. Option out, out, out. Are you all with me? Answer is greater than 30 percentage. What I did is only one value is greater than 30 percentage. So instead of working with 33.33, I just checked 30, 30, 30, 30, 30. This is 30 plus 30 plus 30 into 30 by 100, 69. It is 69. 69 plus 69, 138. Answer is greater than 140. I want greater than 200. Answer option should be definitely greater than 30 percentage. B, C and D. All are out. Are you all with me? Even if the abnormal percentages are given, still you can attack it by using your common sense. In all my classes, what I elevate is the logical ability of you. I hope the idea it is clear. Next one. Key points revisited. Key points revisited. Some important key points, I will write it here. Important key points. Whenever you are listening to the class, kindly keep a pen and write down all the important key points in whatever the way that I am going to specify it. What we are discussing? We are discussing compound interest related problems. Compound interest related problems. Yesterday only 2 problems we did it. Now we will do some more problems discussing a concept. Compound interest related problems. What are compound interest related problems? I do not have any money. I went and asked my friend money. He gave me money. I am using his money for a certain period of time. Because I am using somebody's money, I am liable to pay something extra. I am liable to pay something extra. That amount which I took it, in addition to that, I will pay something extra. That is called interest. There are 2 kinds of interest, simple interest and a compound interest problems. In case of compound interest problems, in case of compound interest problems, in case of compound interest problems, amount at the end of the year, amount at the end of the year becomes the principal for the next year. Amount at the end of the year becomes the principal for the next year. Becomes the principal for the next year. In case of simple interest, rate of interest remains the same every year. Simple interest, rate of interest on principal. First year, whatever the principal is there. Second year also it will be the same principal. Third year also it will be the same principal. Principal does not change in simple interest. But after first year, in case of first year, simple interest and compound interest both are same. After first year, amount at the end of first year becomes the principal for the next year. Amount at the end of the second year becomes the principal for the next year, so on and so forth. In case of simple interest, interest is calculated only on principal. Whatever the sum that I have to give, on that apply rate of interest percentage. But in case of compound interest problems, in case of compound interest problems, in case of compound interest problems, interest is not only calculated on, interest is not only calculated on the principal, but interest is also calculated on the interest which we got. Suppose in the second year, I want the compound interest. Rate of interest on principal we will take, and also interest on interest also we will take. Interest is calculated on the principal as well as interest. But in simple interest, interest is calculated only on principal. That is the reason compound interest values are always greater than simple interest values, greater than first year. CI is always greater than SI if it is after 1 year. Greater than 1 year, compound interest value will always be greater than simple interest value. We will use these fantastic key point to solve a very tough question very easily. CI is always greater than SI for greater than 1 year. So in case of compound interest problems, interest is calculated not only on the principal but also on the interest, compound interest. Now, another important key point, whenever there is a banking related keywords, banking keywords, in case of banking, I will always use compound interest. In terms of banking related keywords, I will use compound interest. Now, how compound interest problems can be solved? Yesterday, we have discussed some important key points. Compound interest problems. Compound interest problems, how it can be solved? What are the ways to solve a compound interest problems? Compound interest problems, how we can solve it? There are many ways to solve compound interest problems. First one is the formulae method, which Anil Nair students will definitely don't use it. One is formulae method, which is amount equivalent to P into 1 plus R percentage power N. Amount equivalent to P into 1 plus R percentage power N. Sir, can you please prove it? How this formula it is obtained? That also I will prove it in the next slide. Next is successive percentage method. Next is successive percentage method. What is successive percentage method? A plus B plus AB by 100 percentage, A plus B plus AB by 100 percentage. If you are able to convert the percentage into fractions, we will also use successive change method. We will also use successive change method. What is a successive change method? Convert the percentage into fractions. Convert the percentage into fractions. Convert the percentage into fractions. These are the three methods which we will use to get the answer option. One is formulae method, another is successive percentage method, another is a successive change method. Second and third, second is writing directly the percentage, third is converting the percentage into fraction. Converting the percentage into fraction. Suppose if answer options are given, if answer options are given, what are the various ways to eliminate incorrect answer options? To eliminate incorrect answer options. These are the methods which are used to say that this answer option is definitely incorrect. These are the ways to eliminate incorrect answer options. What are that ways? This will give you the answer and this will tell you which answers are definitely incorrect. Which answers are definitely incorrect. What are that ways? One is a digital sum concept. If a digital sum is not matching, then the answer is incorrect. And the next one is unit digit concept. Next one is unit digit concept, and the last one is divisibility rule concept. Two problems I did it in yesterday's session to explain these concept: digital sum, unit digit, and divisibility rule. The one which I wrote it on the right hand side will tell us which answer options are incorrect. The one which I wrote it on the left hand side, these are the approaches to get the answer. Good number of basic problems we did it. But yesterday when I discussed one important key point, compound interest behaves like a geometric progression. Compound interest behaves like a geometric progression. That concept we will take it right now and we will use it. So these are the various ways. We will also see right now how these formulae came. Yesterday I told you why the proof of simple interest is PTR percentage. Now I will prove it to you why it is P into 1 plus R percentage power N. Some things which we already did. Yesterday we also discussed Pascal's triangle. Another concept which we discussed, Pascal's triangle. It is used when the rate is 10 percentage. Directly if R is 10 percentage, it will go as per the coefficients of A plus B power N. It will go as per the coefficients of A plus B power N. Almost a good number of problems we did it. Now, next slide is extremely important, sir. Suppose if I take principal as 100, principal as 100. My friend gave me 100 rupees, I used it. So after 1 year, it is a 10 percentage more. 10 percentage extra I will give him. What do you mean by 10 percentage extra? I told you what do you mean by percentage increase. 10 by 100. On 100, 10 more I will give. That means amount after first year. Amount after first year, it is 110. amount at the end of the first year becomes the principal for the second year. Output after the first year becomes the input for the next year. On 110, again 10 percentage increase. 10 percentage increase. So this will become 121. 121. Are you all with me? 110 into 1.1. 110 into 1.1. Again, amount at the end of the second year becomes the principal for the next year. Again 10 percentage increase. So it is 133.1. Again 10 percentage increase. 133.1 into 1.1, 146.41. 146.41. Listen carefully, sir. Listen carefully. 10 percentage increase. 10 percentage is increase is into 1.1. Are you all with me? Into 1.1. Why 1.1 we got? 10 percentage is 1 by 10 increase. 1 by 10 increase. Whenever there is a percentage increase, denominator denotes the initial value. So it is 10. On 10 there is 1 increase. This will become 11 by 10. 11 by 10 is into 1.1. 1.1 is 11 by 10, which is right here. It is again 110. 10 percentage more. 10 percentage is 1 by 10 more. On 10, 1 increase. It is 11 by 10. Again it is 1.1. Similarly, again it is 1.1. Again it is 1.1. Listen carefully, sir. Again it is 1.1. Here it is 1.1. Again it is 1.1. Again it is 1.1. Again it is 1.1. So the multiplication factor, it is the same. What is the multiplication factor? Which is 1.1. What do you mean by 1.1? 1.1 can be written as 1 plus 0.1, or it can be written as 1 plus 10%. It can be written as 1 plus 10 percentage. So multiplication factor, first thing, multiplication factor in some textbooks, in the CBSE and other textbooks, it is also called as a scaling factor. It is also called as scaling factor. It is also called as scaling factor. That remains the same. Multiplication factor remains the same. Multiplication factor remains the same. That means multiplication factor, let me call it as X. That can be written as 1 plus R percentage. So from now onwards, whenever I am doing the multiplication factor, that is called as 1 plus R percentage. 100 into 1.1 is 110. 110 into 1.1 is 121. 121 into 133.1, it is multiplication factor is 1.1. Multiplication factor remains the same. Multiplication factor remains the same. Now if you see here, amount after first year on 100, it is multiplied by X. Are you all with me? On 100 it is multiplied by X. X is 1.1. Now if you see amount after second year, it is the output. Amount at the end of the first year becomes the input for the second year. So it is on A1 I am doing X. Are you all with me? On A1 I am doing X. Similarly, amount at the end of the third year, I need to give some input. Amount at the end of the second year becomes the principal for the third year. Are you all with me? So P we will replace 100. 100 is X. It is into 1 plus R percentage. Here it is P into 1 plus R percentage into X, it is whole square. A2 it is P into 1 plus R percentage whole square into 1 plus R percentage, P into 1 plus R percentage power 3. Therefore, amount at the end of the year, it is always given by 1 plus R percentage power n. I hope the proof is crystal clear to you. If you have not understood How come we are getting the formulae? Then probably usage of formulae you will be struck. Always I keep saying it in all my classes. A formulae is derived from the logic. Formulae is the output, logic is the input. If you apply logical steps one by one, the output which you get is called formulae. Formulae will not give you logic. Through logic, your formulae is obtained. Through formulae, logic is not obtained. Again, I am repeating, very, very important slide, sir. We will study compound interest in a very easy way, very systematic way, multiple angles to solve a problem, right? Why? Because I want my students to be different from others in the domains which I am teaching. If I change the question, you should say to your friend, because you changed these question like this approach is the best. You should be able to teach it is with 100% effectiveness. I hope it is clear. Amount at the end of the first year. Amount at the end of the first year. On 100, I applied 10% more. 10% more. It is given by 1 plus R percentage. Amount at the end of the first year becomes the principal for the next year. It becomes the input for the second year. A2 it is A1 into X. A1 is P into 1 plus R percentage whole square whole cube, so on. So the formula for amount is P into 1 plus R percentage power N. Proof is clear. Compound interest is how much total I gave to minus how much total I took. How much I gave minus how much I took. The extra money, it is called the compound interest. Proof is clear. I hope the idea it is clear. Now another important key point. Another very, very important key point. I will write down at the top. I'll write down at the top. Multiplication factor. I will always use these multiplication factor to solve my problems. Multiplication factor. It is given as X. It is R percentage more. Rate of interest is always percentage increase. So this can be written as 1 plus R percentage. Multiplication factor is given by 1 plus R percentage. Is this clear? Now listen carefully. Some important observations. Principal, it is 100 into 1.1. Amount after first year 110. Again into 1.1. Amount after second year 121. Again into 1.1. Amount after third year 133.1. Again 1.1. Amount after fourth year, it is 146.41. It is 146.41. Now see here, this is after 1 year. After 1 year. This is after 2 years. This is after 3 years. Always the ratio, it is constant. That means P, A1, A2, A3, and so on up to AN. They are all in geometric progressions. They are all in geometric progressions. They are all in geometric progressions. Now see here. Suppose if I am taking from P to A1, P to A1, totally it is 1 year. What is the multiplication factor? Into 1.1. Am I right? If I am taking from P to A2, P to A2, totally how many years it is? P to A1 is 1 year, A1 to A2 is another year. If it is 2 years, from here to here, 1.1 into 1.1, it is 1.1 whole square. It is 1.1 whole square. Suppose if I am taking P to A1, A1 to A2, and A2 to A3. How many time intervals are there? 1, 2, 3. So 3 time intervals are there. 3 years it is over. It is 1.1 for 3. Similarly, if it is 4 years, it will be 1.1 power 4. Similarly, if it is n years, it will be 1.1 power n. 1.1 power n. Are you all with me? 1.1 power n. So we can tell that time period is going in arithmetic progression, whereas Multiplication factor is going in geometric progression. Multiplication factor, it is going in geometric progression. 3 years 2 times. If it is 4 year, if it is, for example, 3 years 2 times. 3 years 2 times I got. I want 8 years. 8 years means number of times. It will go in geometric progression. So 4 times it is 6 years. And 8 times it is 9 years. 8 times it is 9 years. Time period will always go in arithmetic progression. There is a multiplication factor. If it is 2 years, 1.1 whole square. If it is 3 years, 1.1 power 3. If it is 4 years, 1.1 power 1. For an equal time intervals, that multiplication factor will keep multiplying. If it is for 2 years, 4 times. If it is for 2 years, 4 times. If it is 16 times. So this will grow GP, this will go AP. That means, for example, a certain sum goes 2 times in 5 years. Goes 2 times in 5 years. To go 125 times. To go in, let me write down here. Certain sum goes 5 times in 6 years. 5 times in 6 years. Number of times it will be in GP. Number of years it will be in AP. So next, if it is 25 times, if it is square here, it will be double. 12 years. If it is the cube here, 125 times, it will be triple here. 18 years. If it is 4 times, 624 times, it will be 6 4s are 24 years. This is the behavior of compound interest. This is the behavior of compound interest. 1.1, 1.1 square, 1.1 cube, 1.1 power 4. 5 power 1, that could be 1.1, that could be 5 power 1, that could be 7 power 1, that could be compounded quarterly for equal parts. For an particular time period, if it is going x times, if it is double, then x will become x square. If it is becoming x square is becoming x cube. Multiplication factor will be in geometric progression. Time interval will be in arithmetic progression. Write down these important key point in your notebook. Multiplication factor will be in geometric progression. Time intervals will be in arithmetic progression. Time intervals will be in arithmetic progression. I will discuss this by taking a lot of questions from Google and an open source information. We will take a lot of previous year CAT questions, lot of staff selection commission questions, a lot of questions which came in various American mathematical Olympiad competitions also. I hope you are all ready, right? Again, I am repeating it. Multiplication factor goes in GP, time interval goes in AP. Time interval goes in AP. One by one we will see.